don't have one for the moment. But okay, great. So, folks, you may have seen Zach on here on a previous workshop as well. So, yes, he did a workshop on data DAOs, and now talking about compute over data on the FVM. And this is a new workshop that I've not seen yours. So, yeah, I'm looking forward to this. Yeah, if you want to start, like I said, I'm just going to quickly grab a coffee. You start, and I'll be right back here again.
Sounds good. Thanks, Matt. Yep.
Thanks.
Hey, everyone. Back again. My name is Zak Ayesh. If you don't already know me, I'm a developer advocate with the FVM team. Yep. Colleagues with Matt. I've worked in Web3 for almost 3 years now, and I'm a really big fan of decentralized infrastructure, which is why I'm here. So today I want to talk a little bit about compute over state versus compute over data. These are actually two different subjects. I'm going to introduce you to the project Bacalao, which is a compute over data project. And we're going to go over some remix code and then some code in this new hard hat kit that has been created. So quick overview, review. If you don't already know, the FVM brings on-chain programmability to the Filecoin network. And so you may be asking yourself, what does that have to do with compute over data? Isn't this already compute over data, right? Like it's a virtual machine. It's running computations. There's data in it. What do I mean by compute over data? Right. So first of all, the architecture of the FEM is based on WebAssembly. It's built to support multiple runtimes. And the primary runtime it supports right now is the Ethereum virtual machine, or the FEVM, we call it, Filecoin Ethereum virtual machine, right? So all code that can compile down to Ethereum bytecode, whether that's Solidity or Viper, can be run within this virtual machine. And in the future, perhaps there'll be other virtual machines. Right. And so what is compute over state? Compute over state is essentially, Filecoin is a blockchain that was tailor-made for storing the internet's data, right? It's a blockchain based around decentralized archival storage. And then we've added in this, EVM to it, so now we can have programmable storage primitives. But, the virtual machine itself is actually just computing the state of the data stored off-chain with these storage providers, right? So on Filecoin, storage providers store data, and they provide proofs to the blockchain that data is actually being stored, right? And so compute over state, which is what the FEVM can do, is computation around the metadata of the data stored on with the Filecoin storage providers. Basically, compute over state, if you hear that, it just means the storage deals. Compute and the FEVM around storage deals, right? So what is compute over state? Let's look at some deals and see what the state I'm talking about is. I'm going to have to reshare because I'm just sharing this one tab. Right. So here's a deal on the Filecoin blockchain, specifically the hyperspace testnet, which will be deprecating soon for calibration net. Just an FYI. Probably by the end of this month, we'll have calibration net up and running. But hyperspace testnet here, we have a deal 1652, right? And all of this right here, this is that state that we're talking about. The deal ID, the time that the deal was created, the block the deal was created, the PCID of the data that's being stored with the storage providers, right? This is important. We'll talk about it in a second. Whether this deal is verified, and who the client is storing the deal and who the provider storing the deal is. You can write a lot of interesting logic around this, right? You can have a DAO create deals. I did a talk on that earlier in this hackathon. You could create perpetual storage contracts around this data, but none of this data is actually touching the data off-chain, right? Why isn't it touching the data off-chain? Well, a lot of storing data on-chain is extremely expensive, right? And the data we want to store off-chain is large data sets. Maybe it's a whole video. Maybe it's multiple videos. All of that data would be extremely expensive to store on-chain. So we store it off-chain and have proofs to prove that they're still being stored, right? So earlier I showed you that PCID that's part of a deal. Now you can think of that as sort of a root hash that represents the data. We're going to be using these a little bit later on, so I want to review this if you don't already know it. But you can think of it as a hash. It's more complex than a hash. So essentially you take a file, any piece of data, you prepare it into what we call a car file and create this IPLD DAG. If you're familiar with Merkle trees, binary Merkle trees in Ethereum or Bitcoin, you'll be familiar with the Merkle DAG, right? That's essentially what it is. And at the top, we get this like root hash or CID, and that represents that data set, right? That piece of data. So, originally, if you wanted to make deals, you would have to go through storage providers and figure out what they were offering and, go into the market, and you would manually call an API and get your data stored, right? But now that we have the FEVM, you can use what's called the client contract. The client contract will emit an event that storage providers can listen for and take the data that the client contract is referencing and store it and generate that deal that we saw on chain earlier. Right. So all of that's based around compute over state, right? And I talked about the client contract in a little bit more detail in my last talk. So please reference that if you want to learn a little bit more. And that's kind of what we've been focused on here for a while is compute over state. But many blockchains can do compute over state. What is compute over data, right? So this is actually computations over that heavy data that we have stored with storage providers. This may be too expensive to run on chain. Could cost, who knows, $1 million of gas if you were to run these computations, right? So when we say compute over data, we mean compute over the actual data that's being stored with the storage providers. And when we say compute over state, we mean computation in smart contracts over any kind of state that the virtual machine knows about. Right, so here's kind of a visualization of what I'm talking about. We have the layer one, we have the actual Filecoin blockchain right here with the FEVM or FEM on it. And that's where we can run comp over state, right? And then we have layer two, which is the storage providers, which are providing zero knowledge proofs onto the chain. And that's where we want to run computation over data, right? We want to run it off chain alongside these storage providers, right? But storage providers, they're there to store the data. They're not actually running any programs to run any computations. So how can we run heavy compute off-chain? This is where the Bacalhau project comes in. So Bacalhau is, I believe, Portuguese, right? It's a famous dish in Portugal, salted cod, funnily enough. So we had a big Filecoin summit in Lisbon back last October, and I tried Bacalhau. Very delicious. But this Bacalhau is a framework for off-chain computation, right? It's a platform for fast, cost-efficient, and secure computation by running jobs where the data is generated and stored. So, right there by the storage providers. And if we look through their docs here, you'll see a bunch of instructions on like why Bacalao is important, getting you running with Bacalao really quick. And I like to go to the architecture here. So you see Bacalao is itself a decentralized network. It's just not a blockchain, right? So Bacalao itself is a network of nodes that communicate with each other, for instance, using libp2p, which is what Filecoin and IPFS use to communicate in their peer-to-peer networks. And they run jobs on this other decentralized network and post the results on-chain, kind of similar to how storage providers store data off-chain and post proofs on-chain, right? We want to take the most expensive parts, move them off-chain, and only have business logic, only like core important logic toward the functioning of the app on-chain to save costs and space. So one cool thing you can do with Bacalao, and one thing I'm going to run through in a bit, is Project Lilypad, right? So with Project Lilypad, you can actually invoke Bacalao from smart contracts by emitting an event. So very similar to the client contract we have, which emits an event and gets data stored with storage providers. Now you can emit an event and have computation run, right? And we'll see how we can define this computation in a second, right? So yeah, you know, Project Lilypad is what it's called. It's basically a bridge in between Filecoin and Bacalao. And let's check out the repo right quick. Right, so here at github.com, you're at the Bacalao project /Lilypad. And you'll see here, we get a nice README, explains how to use it. If we go into hard hat and contracts, these are the main contracts that we're going to need to interact with in order to interact with Lilypad, right? So one of the most important ones is the Lilypad caller interface. This contract defines the interface that any contract that you make needs to inherit if it wants to run a job on Bacalao from a smart contract, right? And it's pretty minimum. You just need to have this enum and two functions that you can define called Lilypad fulfilled and Lilypad canceled, right? You'll see in a bit, but like Lilypad fulfilled, we're gonna call a function in this contract that'll emit the event that we need to emit, and Bacalao will run the job, and then it will call Lilypad fulfilled once it's done with its job and post the results on chain. Or it could call Lilypad canceled, in which case the job gets canceled for whatever reason, and it can't be run. We also have Lilypad events, which you're also going to want to inherit. It defines a lot more. It's an upgradable contract using OpenZeppelin, universal upgradable proxy structures. And this gives us a little bit more of that, more of the like structure that we're going to need in order to run these jobs on chain. And you'll see here we have two events, Bacalao job submitted and Bacalao job results returned, that your contract will emit when you submit a job and when the results are returned, whether that's fulfilled or canceled. And so if we go into examples, you will see there's a bunch of example contracts, including one we're about to use in a bit. One of them is called Stable Diffusion Caller V2, right? And this will actually call Stable Diffusion in Bacalao, and run it based on a prompt that you give it on chain and return the CID of the image it generates. And you can look it up on IPFS, which is really cool. It'll automatically post it onto IPFS for you. So we can generate.
Zach,
Yeah.
can I ask, can you just zoom in a little bit further on that
Sure.
screen?
How is that? A little bit more or?
One more? Yeah, one more if you could. Fantastic. Yeah, that's great. Thanks.
Awesome. Yeah, no problem. Yeah, so this will call LilyPad or Bakilao, generate an image from a prompt, store that image on IPFS, and post the CID of that image back on chain, which is really cool. So you can get, NFTs have an NFT collection with AI generated imagery and, interact with this all on chain. So yeah, this is LilyPad. We're going to be interacting with some more of these contracts in a second. Another really cool project is Water Lily. I know Bakilao is still pushing this forward, but I think this is a fantastic project. Essentially, this is, as it says, ethical generative AI art. One problem with current AI art generators is that the AI art generator goes around and samples all of these artists' styles on the internet, and then kind of conglomerates them and generates art based on that without giving credit back to the original artist. And Water Lily, credit is given to the specific artist that the AI may be imitating, right? So it's a little bit better for the artists all around to pay them for the work that they've done to generate these styles. So you can give it a prompt. It defaults to a rainbow unicorn in space. And you can pick a specific artist style that you'd like. You need to have a MetaMask wallet with mainnet fill in it. So I'm not going to use it now, but you can see some of the feature artists and their art here. But I just think it's a really cool project. You can find instructions. Just click on to see how it works here. It'll take you to this Notion page. And I know a lot more work is being done to Water Lily, so I'm excited to see where it goes. Right. So let's look at that stable diffusion caller contract that I showed you in the LilyPad repo, and let's look at it in Remix. So if I go here to contracts, I've already loaded in all the contracts we need. So I'm on remix.ethereum.org. If you're not familiar with Remix, it's an online IDE, so integrated developer environment where we can mess around with Solidity code for really any Solidity EVM-based chain, right? And so here we have the stable diffusion caller V2 contract. We have a couple state variables, the bridge address. Now, I didn't talk about the bridge. The bridge is an important contract. Make sure this is zoomed in too. The bridge is an important contract as it is really the contract that acts as the middle person between the contract that we have here, the stable diffusion contract caller, and the Bakilao network, right? So the Bakilao network is listening to this bridge contract for events to be emitted. We have the fee. So LilyPad now takes a fee to run its job. That fee is in fill. It is not like 3 trillion fill or whatever this looks like. This is in like Way or nano fill. So this is really 0.03 fill. Right? A lot more affordable than it looks. We have the struct here for the image that it returns, the prompt, and the IPFS result. And we have our constructor, and the constructor actually requires that bridge address, right? It's not going to deploy without it. We have to tell it where to point, and this allows, if the bridge changes or, someone, runs their own Bacalao cluster and creates a bridge, they can post that address here instead and point to that cluster. And so where can you find the bridge address? We can look at back on our LilyPad GitHub. If we scroll to the bottom, you'll see the current release addresses, and there's Hyperspace, Calibration Net, and Mainnet. And we're going to be working on Hyperspace right now. And you'll see that you'll see an address in the contract proxy address. We actually want the proxy address. So if you're not familiar with how upgradable smart contracts and proxy contracts work in Solidity, the EVM, essentially you have a contract that sits in between the logic and the person calling the contract, right? Just kind of like how a proxy or a VPN sits in between you and a website that you go to, right? So people don't see your IP address, they see the VPN or proxy's IP address instead. And this is typically done so that the logic that's behind the proxy can be upgraded in the future, and their proxy can just change where it points. So you actually want to call the proxy that sits in between, which we'll call the logic. So this is the proxy contract, or the bridge contract proxy that we're going to want here. So if we go to, we'll copy that. We'll keep it for later. If we continue scrolling down and the LilyPad stable diffusion caller, we'll see here that we have the spec for the job. So Bacalao runs all of its jobs in Docker or Wasm. So you can specify either one. The job has to be added to the Bacalao network. You can refer to the Bacalao docs and how to do that. But we already have this stable diffusion job running on Bacalao. You can see it's running with the engine Docker. And these are all of the specs that we'll need to provide in this contract. So when the event is emitted, it knows what job we're trying to call, right? And here we have the function stable diffusion. This is the magic function where we'll pass in a string and it will emit an event and actually, take all that data and call LilyPad bridge and have Bacalao run the job. You'll see here it has a require statement requiring that a base amount of fill is provided in the transaction. It has to be greater than or equal to the LilyPad fee, which again right now is set to 0.03 fill. And if not, the transaction will revert. So you need to make sure that you're sending value with your transaction. I'll show you how to do that in Remix in a second. We have a couple other functions here, but the last two big important ones are LilyPad fulfill. So again, this is where Bacalao will call this function if it has a successful job run and post the results in it. And we have LilyPad canceled, where if it has an unsuccessful job run, we'll call it. And you can see that we've inherited and provided our own logic for these events here. And we have that event upgradable contract. So that's being inherited and imported here, right? So we have LilyPad events upgradable. And we are inheriting LilyPad caller interface right here. So here's those functions that we went over when I went into the LilyPad repo contracts. So we're going to come here and make sure that everything compiles. I'll have auto compile turn on, so it's a green check mark. You can just click the button. If you end up getting some errors, you can always try changing the compiler version 2. I get some errors sometimes with that. I find 8.17 is a great compiler version to set to. Now we'll go one more to the deploy and run transactions tab. This is the tab where we can actually deploy our contract on chain. And you'll see here on the deploy button right beside it, it requires an address, the bridge contract address. So I'll actually post in that address that I copied earlier for the bridge contract, 0x489 4C. We'll double check to make sure. Yep, that is the right address. It's going off. And you can click deploy. And I made a rookie mistake. I still make this mistake sometimes, even though I've done this a million times, right? We need to switch from Remix VM to injected provider MetaMask. And Remix VM is essentially a virtual machine that sits within the browser. Doesn't know anything about any external blockchains. It's just for testing. But we're going to actually go through MetaMask, and my MetaMask is pointed to the hyperspace test net. Right. And so I already have some test fill. There's some tutorials in the Filecoin docs if you don't know how to connect to hyperspace or get T-fill for you to get started. Right. All right, so now we'll hit deploy on our contract with the bridge address in our constructor. MetaMask is going to come up with a notification. We're going to click confirm. And, now it's going to take some time for that contract to be deployed on chain. I actually have another contract that's pre-deployed that we're going to use. But with Filecoin, it takes about 30 seconds for the transaction to be included in the block. And Filecoin runs on something called deferred execution. So after the transaction is included in the block, it's actually not executed until the next block is added to the chain. So it takes about a minute fully for a transaction to be included and then executed on chain. And so instead, we are going to load from this address. So yeah, since Remix already has this contract and it knows the structure and it knows what's called the ABI of that address, we can just load a contract from any address and it'll be instant because it already knows what it looks like, right? So here is all of the functions we can call from this contract. We can click all images, and you'll see that there's already a bunch of images that have been stored from previous Bacalao runs. A bunch of this rainbow unicorn. It looks like a corgi having tea with a king. That sounds like a fun image. Alongside their IPFS CIDs, so we can look back at it, right? And you'll see that the stable diffusion function is in red, which means it's payable. So remember, earlier we said we're going to need to send 0.03 fill to this function for it to run. So I can send that fill over to the Lilybad contract, and Bacalao can get paid for the computation that it's running. I'm sure it's not cheap to run that kind of computation. And so, we'll make up a string. We'll say awesome, a prompt, decentralized storage. And if I was to just click the button here, I'm going to get a gas estimation failed error because of that require statement at the beginning. So let's go find that right here again. Yep, because of this require statement. If I click on it again, you'll see error not enough to run Lilypad job, which is the error we got right here because our message dot value wasn't greater than or equal to the Lilypad fee. So how do we get our message dot value greater than that? You can come up here, and this is for the general account or the transaction structure. We can add in a amount of fill we want to send right here. Now this is, we're going to do it in way, and we'll see the comment right here. You can just post that in here. And so again, this is going to be 0.03 fill. If you ever wanted to do like whole number increments of fill, you could switch to Ether. So, Remix is based around Ethereum, but fill will be the unit of account since we're connecting to Filecoin. And this would be like 3 billion fill, which we don't want to send. You'd want to put like 1 or 2. But we're going to denominate it in a way with this. So this is going to be 0.03 fill. And now I should be able to call this function. Yep, so my MetaMask comes up. I hope it's showing on screen because I don't know if it's part of this window. But a pop-up, I just hit confirm. And it's going to send that transaction through. Right. So it's going to send the transaction through. This is going to take a while, right? So it's going to send the transaction through. Bacalao has to then listen for the job, and it pulls it periodically. I think right now it's every 5 to 10 minutes. It pulls the lily pad bridge, runs the job. That'll take some time. Then posts the results back on chain, and that transaction has to be included on chain. So it will take some time for this to run. We're not going to wait for this specific job to run. But what we can do is we can look up these already included jobs in this contract and see what images are generated, right? So these are all stored in IPFS, so they're open. Let's look up Rainbow Unicorn, right? So I'm going to copy the CID for that. And here I may have to actually share my whole screen to really get this. Why is it not letting me change the screen share out? Can you get it to stop sharing my screen, Matt? It seems to not be working. Oh, I see it right here.
1 second,
actually.
hold up. Okay, you got it?
Yeah, appreciate it. And I will go ahead and share my entire screen. Right. So I actually have the IPFS desktop client running in the background. And, we can hit browse and find it here. And so this was that hash the CID that we got that Bacalao had returned. And you'll see here, it actually returns a whole file structure. But if we go to outputs, you'll see the image right there. And there's the Rainbow Unicorn, a work of modern art with its 3 faces. And yeah, beautiful, beautiful AI art.
That is great. Somebody in the chat, Zach, is asking about the if you could share they say the transaction hash. I'm not sure if they're on about the actual transaction hash of the transaction you just submitted, or if they mean the CID. Like Latos, I'm not sure which one you're after, but if you have the CID, if you can either put it in the Discord, in the Twitch chat if you have it open, or just put it in the chat here. There's a chat button down the bottom of this. You can
I can come back
your Ninja.
So the CID can post right here, and that's the CID for the unicorn picture.
Right, I'll just put that in the chat.
Sweet. And actually, I want to be back here anyway, so I will share my window again. Lots of back and forth with sharing here, so I appreciate y'all's patience. Okay, and so that's like using the desktop client. I also have this handy IPFS companion browser extension, which I think is really cool. And so if I just type in HTTP, I have it here. Maybe HTTPS // and I do ipfs.io/ipfs/ and we're going to put in that CID. And we get exactly what I showed you in the desktop client. We can go to outputs, click on the image of our beautiful AI generated Bacalao image. Right. So, this is kind of the basics of LilyPad in Remix. I highly suggest you go around and check it out. I'll have a bunch of links at the end of this for everything, and QR codes and websites that you can check out. Yeah, we'll go ahead and go back here, and the next part is we have a brand new Compute Over Data starter kit, right? So this will probably be where all of our examples live, migrated from LilyPad. We'll see how we can do it. LilyPad repo will probably still be where all of the main development takes place. This isn't actually linked, so we'll just go away.
Yeah, I'm just going to put the link in the chat. I think if I can find it here.
COD starter kit right here. So we're on the Filecoin project organization, COD starter kit. This is brand spanking new, so literally just got uploaded before this presentation. Yeah, do you want me to post this link in the chat?
Yeah, I'm just looking for it myself. Actually, I'm not sure. Is the repository? I know you literally just uploaded it. Is it? Oh yeah, no, I can see it here. Sorry, for some reason
You got
I couldn't.
it. Sweet.
Yeah, I got it here, so I'll put it here in the chat.
Yep. This right now basically just has the LilyPad like interface contracts and that Stable Diffusion caller v2. But it also has a hard hat task I created, some of the basic ones, and then the task I call as Stable Diffusion method. Right. And so I really do expect to be working along the Bacalao team and making this a more robust kit as time goes on. But yeah, you can clone it onto your local machine. Come here, copy this, go into a terminal, type git clone, paste it in, and you'll get the repo cloned in. And I'm going to switch my monitor one last time to VS Code this time. All right, so this is the COD kit, and I'll zoom in here, so hopefully it's easier to see. And just like the starter kits, if you aren't familiar with the hard hat starter kits or the deal making app kit or the data DAO kit, it works very similar to all of those. So if you want a little bit more in depth, I suggest watching a tutorial on one of those. But yeah, you see that the structure is just like we saw on GitHub. When you first get in here, you're going to type in yarn to download all your packages, hit enter. And then you can hit yarn hard hat deploy, and it will run the deploy script, which just deploys this single Stable Diffusion caller v2 contract. And it's already deployed. I've already deployed this and compiled it. So, it would compile normally and deploy, but it says here it's reusing the one that we've already deployed at this address, right? And yep, you can check your deployments here. If you ever forget the address, it's also right here. If we go into task, Stable Diffusion.js, this is the hard hat task that calls that method I was talking about that I showed you in Remix. And it takes in the address of the contract that we're pointing to. So it'd be this address and a prompt, just like we saw earlier. So this is just doing it from the command line. And I think the important detail here is, if you're not used to it, when you send the transaction, which is here on line 25, await stable diffusion caller v2 dot stable diffusion. We're going to pass in the prompt from our task args, but we also need to pass in that value, right? Because again, this is a payable function, and it's not going to go unless we pass in that 0.03 fill, right? So you can do that by creating this object, a JS object value, and use this ethers utility from ethers.js, parse ether 0.03 ETH, but in this case, fill. And it will send, and we include it in. So this is our actual argument, the prompt, and it will add in that object there, and it'll know to send 0.03 fill when I send that transaction. Right? So if I was to call this, I'll do yarn hard hat stable dash diffusion. Stable diffusion. We'll do dash dash contract. And we'll call this contract. We'll do dash dash prompt and do awesome decentralized search. Enter. And you see it's going to say sending a prompt to stable diffusion running a Bacalhau on network hyperspace. And yeah, this will go through. And again, 30 seconds to get included, 30 seconds to execute. Bacalhau does it, returns everything just like we showed you on Remix. Well, this is done in Hard Hat now. And of course, for all this to work, you want to also make sure that you have your environment variable here, your private key that you never show to anyone else. The get ignore is already set to ignore this, but it needs this so it knows what wallet to use when transacting on chain. And yeah, so this is just a brief introduction to the COD starter kit. Excited to see where it goes from here, and we're definitely open to contributions for it. And I'll just close out the presentation now. Right, so you can check out Bacalhau more. These are some links, github.com/Bacalhau project/lilypad for that repo I showed you, the Water Lily repo, and the Twitter and YouTube handles for Bacalhau to get the latest on the development of that project. And some more of our app kits. If you're hacking in the hackathon and want some inspiration, there's the DataDAO app kit, the Foundry starter kit, the Hard Hat starter kit. And these starter kits just have very basic contracts in them to get you started interacting, nothing too specific. The deal making app kit, this is a kit specifically for making deals using that client contract I said earlier. And finally, we have this link tree for a bunch of other useful resources on the FVM and the docs and everything you may need to get you started hacking on the Filecoin virtual machine. So yeah, thanks for watching. I hope you learned something. I hope this was helpful and inspires you to build cool things on the FEM using Bacalhau with compute over data, and really just getting the best of all these new technologies that are coming out. Decentralized infrastructure with heavy compute and AI. It's going to be really cool to see the possibilities of these two technologies combined. So yeah, I don't know if there's any other questions, Matt.
Cool. Yeah, there's some questions coming in. Well, I had one first of all, which was just about when you ran that command just now to ask it to generate something from that prompt. Does it actually block until like Bacalhau has finished and it comes back with the actual result, or do you get some sort of intermediate thing that you then have to go and check to see? Because you said that Bacalhau is going to take, say, 10 minutes or so possibly to actually process it, or 10 minutes before it might pick it up. So do you get like back some like job ID or something, or does it literally wait there until it's finished?
Yeah, exactly. If you like, yeah, you got it. Like, the transaction will go through, and when it's done, it's just done in an admitted event, right? So that's when
Right.
that transaction is done, when you call the stable diffusion. But then, yeah, backlog will run, and when it calls either the job fulfilled or the job canceled, it'll return like a job ID, and it'll return an image and store that data in a struct or a array uh, on the smart contract itself. So you'd have to pull to
Right.
see when it returns.
Okay, so you pull this. So once it's Backyao is finished, it will update some data in the smart contract. You then inquire on the smart contract to say, "Hey, has this finished running?"
Yep, exactly.
Okay,
Yep.
cool.
Yeah, great question.
Okay, so there's another couple of questions in the chat from Nick. First, can we tell LilyPad to call a job that we're going to create from our custom contract?
Yeah. Yep.
Yeah.
So you can go to the Bacalao docs, and they teach you how to like add your own job to Bacalao, like the network. And all you have to do, so like the LilyPad caller contract that is in the kit and in LilyPad, that just kind of defines, like, it's just an example to show you how you could make your own contract, right? You can make your own contract. You can reference a different job that's not stable diffusion, and make that call. I just know LilyPad does need that payment of 0.03 fill at the moment on the bridge, so you just need to make sure that the interface is compatible, it has those functions, and you're good to go.
Yeah, and that's something worth saying, is that Backyao is a general purpose, like, decentralized compute platform. There's a whole load of stuff that you can do with it. Actually, if you want to find out more, I'll try and find the link in a second. But there were some really good talks at the Compute Over Data track at IPFS Camp that was in Lisbon towards the end of last year. But also, whilst we're on that subject, coming up next week, there's the Compute Over Data Summit 2023, which is in Boston, Massachusetts, and Zak is going to be there speaking and doing another demo. So if you want to kind of find out more kind of in person, then certainly come along to that. There's going to be a whole load of stuff about Compute Over Data, a whole load of stuff about Backyao. I'm just going to put the link in the chat as well. So yeah, there's one more comment from Nick as well, a question from Nick. Is it possible, do we have to run Backyao? So no, you don't have to run your own node, do you, as far as I'm aware?
Nope. Yeah, that's you can just communicate with the current networks that are online, which
Yeah.
is what I was doing. I'm not running a Bacalao node in the background anywhere.
Right. And this is another area where, like, Backyao and FVM are quite well suited to each other, because again, Backyao doesn't have any like inbuilt payment mechanism or anything like that right within it. So using tools like FEM and using things like this, you can actually then pay out and reward the compute providers, or the content creators in the case of this case, various things you can then use FVM to sort of manage that sort of payment side of things, which is pretty cool.
100%. Yeah, they mesh really well together.
Yeah. So Nick is just saying, so we only need to create the job. Yeah, that's correct. You only need to create the job. So within FVM, you emit an event that describes the job you want to run, and Backyao will pick that up and run that job.
Now, Bacalao is open source and open, so for whatever if you decide you want to run your own Bacalao node, you can. It's an option, but you don't have to.
Yeah, exactly. Anybody can join in and run their own node on there. And there's all sorts of interesting things you can actually do with Backyao. I saw a great demo in which they were actually using Backyao to load data into IPFS. So they actually had a Backyao job that went off and fetched a bunch of stuff via HTTP and loaded it into IPFS. So it's just, if you've got a large amount of data, sometimes just literally loading it into something like IPFS can take some time. And they're actually using Backyao to do that in a kind of a decentralized fashion. They had a whole bunch of data that needed to be uploaded. And so they used that, which was pretty cool.
Yeah, those things really like excite me, because it's like, on chain you can do a lot, but you're also limited by all the limited resources on chain, right? All these nodes have to be run all this data, and you can't do these like kind of things completely on chain, or it would be way too cost prohibitive. So yeah, these kind of ideas like open up a whole new realm of possibilities, and I'm excited to see like where people take this and the cool things they come up with.
Yeah, and that's one of the things that some people don't necessarily kind of appreciate. I suppose when you first hear Filecoin and you hear FEM, one of the things that people think is that you can instantly access, say, IPFS or Filecoin, data, large data, and run compute jobs on FEM itself, which you can't do. And one of the main reasons being is that jobs on a blockchain are being executed across the entire network, so use up actually quite a lot of resources, and those resources have to be paid for in gas fees on the network. So your compute job, unless it's something very, very, very trivial, is going to cost an exorbitant amount in terms of gas fees, and may not even you may not even have enough compute sort of time and power in which to run that job. If you think about it on a blockchain, if each block, in the case of Filecoin, each block is only 30 seconds, that means no compute job could ever last longer than 30 seconds or and be included in a block, right? So that's why things on smart contracts are very simple. They're sandboxed, they're restricted in what they do because they can't hold the chain up. Whereas with something like Bacalhau, you're able to do this off-chain compute. So if you've got some processing task, some big data processing task that is going to take hours to run, then you can run that on Bacalhau and then just report the status of that back to FVM, and then use FVM as the kind of like the controller, the mechanism by which these things are orchestrated, paid for, verified or validated, whatever it might be. You could run a compute job on Bacalhau and then get FVM to mint, say, some sort of like certificate as an NFT that basically gives some sort of stamp of approval that job has happened at a particular time or was run on a particular node or whatever it might be. So you could actually use that as a certification process on top of the actual compute process that's done on Bacalhau. So yeah, that stuff's really cool. That was a really cool demo, Zach.
Thank you very
Thanks.
much.
That's good to see that. So, okay, so coming up in a bit, we've got about 5 minutes or so, I think, until the next speaker that's coming up. So the next chat that we've got is Stephen that's coming up from Axelair, that's going to be talking about Axelair. So just waiting on that. So why don't people, if you want, hop off, go and get yourself a drink, bathroom break, whatever, and hopefully we'll be back in about 5 minutes. I'm just going to leave the stream running. So I'm going to do that and then see you back. But thanks a lot, Zach.
Thanks,
great.
man.
And I'm looking forward to seeing you next week in Boston. So that's going to be
It's gonna be fun.
Cool.
See you
Okay.
there. See you, everyone.